Lots of fun today in college algebra. This is 6-4. Still dealing with the idea of zeros. Talk about factored form. Talk about polynomial form. Here's what they're giving me here. It says write the equation of the polynomial whose zeros are given and the degree is given. So they tell me the degree is 3. You know it's going to be a cubic. They give me 1, 2, 3 different zeros. We will first write this in factored form. Hopefully it rings the bell. If 2 is a 0, then that means x minus 2 is one of those factors, right? So it's just the opposite, because doesn't 2 make that blue parenthesis turn out to be 0, right? Then this parenthesis with 5 would be x plus 5, because doesn't negative 5 make that red parenthesis turn out to be a 0? And then finally x minus 3. This is that polynomial in factored form. Good to note that, because they're asking a lot of questions. Put it in factored form. This is in factored form. Then they want us to expand it out, right? So we've got to multiply it all out. So I got to take a binomial times a binomial times a binomial. There's no real shortcut to do that all at once. You can only take two things times each other at a time. So I got to take Mr. Blue binomial times Mr. Red binomial. What's that process called when you multiply that all out? FOIL it. So first terms times each other, outside terms times each other, inside terms times each other, and last terms times each other. Cool. Before I bring that green thing down, I'm going to combine my like terms on this Mr. Purple guy. So x squared plus 3x minus 10 is what that really is. I still got to take all of that stuff times the green guy. This is where, I know you've done this many times before, but it gets a little confusing. Before you get started, you need to realize you're taking 3 purple guys times 2 green guys. 3 guys times 2 guys should give you back 6 guys. Right? When you multiply this out, you better get 6 terms back. Then maybe they're like terms. The way that I roll is I start with this guy, and I take him times every green dude first. X squared times x is x cubed, and x squared times negative 3 is negative 3x squared. Then I lightly cross him out to realize I have used you. Right? Done with you, Mr. X squared. You need to now take 3x times every green guy. So 3x times x is 3x squared. And 3x times negative 3 is negative 9x. Right? Done with you. Finally, negative 10 times all that stuff, negative 10x plus 30. Time to combine like terms and write it as a polynomial. So the first move is write p of x, because there's your polynomial. P of x equals. It should be a 3rd degree guy. So here's all your x cubes right here. I lightly cross him out. Here's my x squared. Total of none, right, because they add up to be nothing. X's minus 19x and constant 30. If you really wanted to see if you are correct, you could punch this in your calculator to graph as y1. You could punch this in your calculator to graph as y2, and they better be the exact same thing if that's correct, right? So it's a way you could check if you really wanted to. Don't forget p of x at the end, because it's a polynomial, what they're asking for. Cool with that? Number 2, let's put him in factored form. They give me zeros. It's supposed to be a 4th degree polynomial. They give me the zeros of negative 3, and it's got multiplicity of 2, 2 and 1/2. So when I start with this negative 3, I will put x plus 3. It's just the opposite of what that is. Since it's got multiplicity of 2, that means that that quantity gets squared. If it had multiplicity of 3, you'd put cubed. If it had multiplicity of 4, you'd put to the 4th power. So this was multiplicity of 2. You'll square it. Then this 2 right here, you'd get an x minus 2. And then this 1/2, those of you that had me last year for Algebra 2 will remember this little trick. Like the denominator is your coefficient of x, right? It's this number's in front of x. Then you put the opposite of your numerator. It's the opposite of this guy over that guy is your root, like positive 1/2. So this is the denominator, same sign. Numerator comes over here with that guy. Cool? Now, all we got to do, this is called, excuse me, that's called factored form, right? That's factored form. They want it in expanded form, so I'm going to do 2 things. I'm going to expand this binomial squared with my shortcut. Go for it. square the first guy, twice the product, square the last guy. Cool? Then I'm going to take blue guy times red guy right over here and get that done right away because I could FOIL those. 2x squared minus x minus 4x plus 2, right? And if you'd like to then realize that that's negative 5x and just erase it and put minus 5x, you can. Those of you that can do that in your head, good for you. You know, Mrs. Colwell likes to teach people to do that stuff mentally. You know, I'm a big fan of just writing it out, erase and put it again, whatever works for you. It's minus 5x one way or another. Cool? Now, we've still got to take green guy times purple guy. 3 guys times 3 guys should get you back 9 guys. So one at a time. X squared, I'm going to take it times every purple dude. X squared times 2x squared would give me 2x to the 4th. There's your 4th degree right there, right? Then x squared times negative 5x, negative 5x cubed, and plus 10x squared. Done with him. The hardest part about this is getting all the little exponents right. I took this guy times each one of these is what I did. 2x squared, not 10x squared. I don't know where I got a 10x squared. Sorry. Everybody cool with that? Yes? No? Maybe? Cool. Then green guy, second guy times everybody. Squared plus 12x. And if you run out of room working to the right, who cares? Just go down below and just write another line underneath. 9 times all that stuff. What color can I use? Green. Plus 18x squared minus 45x plus 18. There it is. Time to write your polynomial. Don't forget p of x equals. You know you got a 4th degree. Finding all your x cubes, I kind of go and underline them. And then realize there's only just those 2 puppies. So that is a total of 7x cubed. And then x squared, you should have more than 2 of them. There's 3 of them. So that's negative 28x squared plus 18x would be negative 10x squared, right? Is that right? And then finally, x's, negative 33x's, correct? Plus 18. Pretty simple process, you know, old school algebra, tedious, annoying, watch the exponents, you know, I mean, it's nothing complicated with these because we had real roots. You know, when you get to the imaginary ones, that's where we got a little bit of a problem. But the multiplicity, cool with how to deal with the multiplicity. Yeah. Next one. So I got x minus 6, right? And then if you got 0 for a root, please don't write this, x minus 0. That's ridiculous to write. What do you just write instead? Can't write 0. What's x minus 0, baby? What's x minus 0? It's just x. So if you've got 0 for a root, you put an x in there. And I like to actually put him first because it kind of messes things up. But it's got multiplicity of 2, so it's got to be squared also. Any of those roots of 0, bring to the beginning is the best idea. And then it's supposed to have degree 3, so there they are. There's 3 things. There's 1 blue thing and 2 red things right there. There's your 3 things. So expand. Thank you, pal. Just distribute. X cubed minus 6x squared. Done. Simple. Thank you. Nice one. Next one, not so simple. 4 different guys supposed to be there. First one, check it out. I'm going to write it the long way and then see if you can figure out the shortcut to write it. You're supposed to do x minus that entire root of 2 plus 3i. Right? That's just this one root right here. Then what has to happen is this negative has to get distributed through there. So wouldn't this guy turn out to be x minus 2 minus 3i for a root? Correct? What really happens is it's just the opposite of him, and it's the opposite of him. That's a positive 2, it becomes a negative 2. That's a plus 3i, it's going to become a negative 3i when you put it in the root form. It's just opposite because you distributed the negatives through. You cool with that? So let's see if we can write the next one with a shortcut. If the next root is 2 minus 3i, you got to start with x. Do you want to put a plus 2 or a minus 2? Minus 2. And since that says negative 3i, what's this got to say? Plus 3i. It's just opposite everything. Cool? And then the last one is x plus 1, and it's got multiplicity of 2, so that's got to get squared. Cool? This part right here, piece of cake. This part right here, not a piece of cake. It's going to get nasty. So let's deal with him, and then we'll come back to him later. 3 guys times 3 guys should give you 9 guys right here. X times x, x squared. X times negative 2, negative 2x, plus 3ix, or 3xi, however you want to write it. You know, it's got a 3, it's got an I, it's got an x. Next guy, you got negative 2x again, plus 4, and then minus 6. Wait a minute, something went wrong here. 6i, yeah, there we go, minus 6i. Cool with that, taking this times this, minus 6i. Done with that. Then what color can I go? Minus 3ix plus 6i minus 9i squared. All right, negative 3i times positive 3i is negative 9i squared. Before I even attempt to deal with this, I'm going to clean all this stuff up. All the imaginary stuff should go away when you do this. These roots are conjugates of each other. The imaginary stuff should clear out. So if you don't get it to clear out, you made a mistake. You've got a 3ix and a negative 3ix. They're gone. You've got a negative 6i and a positive 6i. They're gone. Right? But here, who remembers what I squared is again? What's I squared? Negative 1. So you got negative 1 times 9. That's really a plus 9. Right? So I cross him out and put plus 9. Now I will combine my like terms. So I'm starting off with x squared. I've used him. X's, I got some x's here. Total of negative 4 x's. Constants, 4 plus 9, 13. Right? Cool? Are we done? No, we got to do this now. So I'm going to bring him down and expand him right away. Square the first guy, twice the product, square the last guy. But the cool part is all the imaginary stuff's gone now. Yay for being gone. Now again, 3 guys times 3 guys, yippity-doo-dah-day. I did that without crossing stuff out, so I could have made a mistake. I don't like to cross stuff out when people are looking. Here's what you get. What's this called right here? What's this? What form is this called? Factored form. This is polynomial form right here, right? Or expanded form is what some people call it. Yay! A, find all the zeros. B, write the polynomial in factored form. Sweet! How do I find the zeros? I know there'll be, first you should put zeros. How many will there be? graph him. Got him graphed. Looks like -1 is a possibility, so I'll trace -1. Hacha! -1. This guy right here looks like a 2. Let's see. Trace 2. Holla! That means the last guy has to be rational also, because irrationals come in pairs, imaginaries come in pairs. 3, 4, 5, 6. Trace 6. Holla! Sweet. There's our zeros. Write the polynomial in factored form. So, this is part A. This is part B. Part B, write it in factored form. This would be x plus 1 times x minus 2 times x minus 6, and put it equal to 0. That's why it's in factored form, because you want to know when it's 0. Should we expand that out? That's why understanding the names of the terms is very important. They want it in factored form. Is that in factored form? Done. Don't waste a million minutes of your time trying to expand that out. Done right there. Cool? Understand what factored form is. Next guy. Let's graph him and find his zeros. So part A, zeros. There's a possible of shui of them. Let's graph him. Looks like so. -1 looks like a possibility. Yes. -2. Why did I get a 0 there? Oh, because I'm on the wrong graph. That's why. Well, I need to be on this guy. Let's just turn him off. Graph. -2 though, correct? So trace -2. And we got a 0. Is there multiplicity there of evenness? How do you know if there is or isn't multiplicity there? It crosses, right? It crosses it. So that means I got 2 left, so let's synthetically divide. 1, 8, 22, 20. Should be 4 guys in there when that's a cubic. Better get a remainder of 0. I do. I got a sweet quadratic right here. I will solve him however you choose necessary to solve. Since A is 1 and B is even, I'm going to complete the square. Again, if you want to use quadratic formula, use it. Hope you realize they should have been imaginary answers because you couldn't see them. They were playing a nice game of hide and seek with you. Square root both sides and get this. X equals negative shui plus or minus I. So -3 plus I, -3 minus I. That's just part A. Part B wants it in factored form. So, blow it up, Chris. Part B, wherever you got room, you'd have, what would this turn into be? X plus 2. Times the quantity of x, and then opposite of both of those guys. All right, so x plus 3 minus I. And then the last one, opposite of both of those guys with an x. And you need to squeeze an equals 0 on that puppy also. Factored form. Factored form. Cool. Let's keep rolling. How many zeros possible on this? And what about this? And oh, that's funny. 4. Graph him. Holy cow, brother. Difficult to see. How many zeros should there be? 4, right? I feel we are pretty good at finding these zeros. It's just the crazy graphs. How many do you see? Looks like 3. That can't happen. You either will see none of them, or 2 of them, or 4 of them, right? Because don't the imaginaries have to come in conjugate pairs? There are 4 of them there, but you can't see one of them because take a wild guess where he's at. He's at 0 right there also. So if you was to like zoom in on this spot right here, just for fun, if I change my x minimum to -1 and my x maximum to 1 and graph it again, you'll see kinda that you'll see that part crossing the x-axis right there at 0. Right? So hard to see that. Let me go back to zoom 6. You just have to use the knowledge. That's why we try to teach you that they come in conjugate pairs or they come in pairs. It's like there's got to be 4 roots that you see. If you see 3 of them, you have to be able to see the 4th one. Maybe your window wasn't big enough, so I know one of them is at 0 right there, because if you hit trace 0, that's nice. Over here, not nice. Let me graph y equals 0 and see if it's still rational. So I want to second calculate the intersection of this one and this one. Rational, correct. We want it as a fraction though. So -3 1/2 is really what fraction? -7/2, right? You take 2 times -3 and get -6. One more, -7/2. Cool. This guy got to be rational also, so I can calculate his intersection. First curve, second curve, and I don't know where my cursor went. Oh, because I'm on that stupid second curve. This is what happens when you put the y equals 0 below the one instead of on top of the one. You want y equals 0 below him. 1.6 repeating, which is 1 2/3, correct? What's 1 2/3 turn into? 5/3. And then you could trace that one. That one looks like it comes out nice at 1, 2, 3. Trace 3. Does that come out nice? Yeah. So all 4 were rational. Now put them in factored form. Part B. This guy would become 2x plus 7. The denominator comes in front of x. Switch the sign on the numerator. What's this guy, though? Who's he? He's just x. Where should you put him? Put him first. Don't put x minus 0, right? That's just plain old x. Then this 5/3, who's in front of x? The 3. And then should it be plus 5 or minus 5? Opposite of your numerator. And then x minus 3 equals 0. Factored form. Cool. Factored form. One more of these. Nice and fun. Graph him. Should be 4 zeros. I see 2 of them in this window, so that's good news. It means either the other 2 are imaginary, they're off the grid, so I'd have to change my window. -5, +5, where they turn out to be. Do a little synthetic division to find those other ones, which should come out imaginary. I mean, they could actually be, let's say they were like 50 and -50, they could be rational, you just can't see them in your window. Meow, meow, meow. Oh, throw a 0 in there, Mr. P. $25. I did that wrong. 25 minus 16. That's 9, right? Yeah. Is that right? Yeah. Okay. Then divide by 5. 1, 5, 0, 0, 9, 45. Snout. 0. I like this guy. This says x squared plus 9 equals 0. All right, this is x squared. There are no x's. 9 constants. You want to know when it's equal to 0. Subtract 9 from both sides. and x equals the square root of negative 9 plus or minus 3i. So then you can write him in factored form. Factored form, b x plus 5, x minus 5, x plus 3i, x minus 3i equals 0. 3i Joe, he is not an American hero. He's got 3 eyes. G.I. Joe, an American hero. It's Veterans Day. Cool. A couple more. It says find all complex solutions for the equation in the form x squared equals k. I think that should be x to some variable, so like x to the a. I think that's a typo right there. What's the degree on 9, baby? 4. So you know the zeros. How many you'll have, I should say. You should have 4 zeros. Right? You can find the real ones. Should I say real? I should say rational. You can find the rational ones without even graphing now. X to the 4th equals 81. Right? You could 4th root both sides if you wanted to, because there's no x cubed, there's no x squares, there's no x to the 1st. What to the 4th power gives you 81, baby? 3 or negative 3. If you would graph this, you'd have to first get it equal to 0, which we're going to have to do anyway. You'd have to subtract 81 from both sides. And you'd graph that, and I'll tell you, it'd cross the x-axis at 3 and negative 3. So, nice. How do I find the imaginaries? Time to do some synthetic division again. And now you need this red guy, because it has to be equal to 0 before you can synthetically divide. The 4th power's coefficient is 1. There's no thirds, no seconds, no first. There is a constant of negative 81 also. Remember, he's 4th degree. There better be 5 guys in there. So, 1, 3, 3, 9, 27, 81, 0. Knocked it down to cubic. So, synthetically divide by the negative shui. 1, negative shui, 0. 0, 9, negative 27, 0. X squared equals, let's do x squared plus 9 equals 0. X squared equals negative 9. X equals plus or minus 3i. 3i, negative 3i. And that's all they wanted. They just wanted all the zeros. So we do her again. How many zeros will this puppy have? 3. Cube root of negative 64, like what to the 3rd power gives you 64. 4. Can it be negative, though? Is negative 4 times negative 4 times negative 4 turn out to be negative 64? So there's your real rational root right there. And you're left with 2 imaginaries left. That's good. So get him equal to 0. And then synthetically divide. 1. This is x squared minus 4x plus blank equals negative 16 plus blank. I'm going to complete the square on that quadratic right there. Have to be value squared right in there. X minus 220 squared equals negative 12. That's good. Gives me my imaginary answers. X minus 2 equals plus or minus 12. Biggest perfect square that goes into that is 4, and it's got to get square rooted, so it becomes a 2 with an I. How many were left over? 3. If you need to split that up as the square root of negative 1 times the square root of 4 times the square root of 3, you do it, right? But whatever you can handle. Then x equals 2 plus or minus 2i square root of 3. So 2 plus 2i square root of 3, 2 minus 2i square root of 3. Again, if you wanted to use the quadratic formula, it's all good in the neighborhood. Yeah. Finally, answer each question regarding the given polynomial function. List each 0 and its multiplicity if it's greater than 1. So if you got a 0 where it's just a single 0, you don't have to list any multiplicity. But if there's multiplicity, you list it. So any zeros right here? That's an interesting question. Are there any zeros right there? Are there variables right there? This guy doesn't matter. This guy, are there variables involved with him? What value of x would make that turn out to be 0? 5 is a 0 of that. This guy, green, he's got variables also. What value of x will make that turn out to be 0? Negative 3. Is there any multiplicity on this one? Due to the fact that it is being squared, right? So it's got multiplicity of 2. Put it in parentheses. You can just write mult. Because he was being squared, that's going to be there twice, right? There should be, for each real 0, tell whether it crosses or touches the x-axis. So negative 5. Will 5 cross the x-axis or will it touch the x-axis if there's no multiplicity? It will cross. So 5 crosses. And now negative 3, you got to be careful because even when there's multiplicity, they can cross the x-axis. But if it's an even amount of multiplicity, it will touch, not cross. But if that's got multiplicity of 3, it will cross the x-axis. If it's got multiplicity of 5, it will cross the x-axis. This has an even multiplicity, so doesn't he just touch the x-axis? Multiplicity only does that little touching if it's an even amount. Okay? What's the degree of this polynomial? You add all of these up. You use your multiplicity, which is 2. You add this one up, which is 1, right? So what's the degree of this puppy? 2 plus 1, third degree, right? There were 2 zeros here, 1 0 here, total of 3 zeros. What's the maximum number of turning points then? What do you think? Turning points. When I gave you a graph before, and I asked you to find the turning points, there's 1, 2, 3 turning points on that. You found the minimum degree to be turning points plus 1. You have the degree already. You have the degree. So if this is turning points plus 1, then how do you go backwards and find turning points? Subtract 1, so how many turning points? 2. Draw a picture of the end behavior. So you know he is an odd degree. You go back up here and look at your leading coefficient, which is negative, correct? So will the arrows be going the same way or different ways? Different ways. Since that is negative, will it go up right or up left? Up left. Positive is up right. Negative is the opposite of that. One more, baby. Zeros. Does this matter? Yeah, there's a variable there. What value of x will make him turn out to be 0? 0. Any multiplicity on that? No exponent other than 1. Interesting. Right here. Where's the exponent? Inside, right? Multiplicity only happens if the exponent's up here. What you need to do is pull him off to the side and figure out where he equals 0, right? You're wanting to know where these things are 0. Well, I'll figure it out. I want to know when x squared plus 9 equals 0. Wouldn't you have to subtract 9 from both sides? Correct? And what does x equal? Plus or minus 3i in that situation. There's some imaginary roots right there. So you had 3i and negative 3i. You want to know when all of these puppies are 0. It's the same concept that you do on this one also. You'd say, hey, I want to know when x plus 5 equals 0, so you'd subtract 5 over and get x equals negative 5. It's just we're not used to the squared stuff being on the inside, so I suggest pulling it off to the side and set it equal to 0. Isn't negative 5 a 0 here? Is there any multiplicity of this one? Multiplicity of 4, because that exponent is outside the quantity. And then this guy, there's no squared stuff going on. If you really want to pull that off to the side and figure out when it equals 0, you'd have to add 4 to both sides first, then divide by 3, and that would give you a 0 at 4/3. For those of you who have a lot of practice with that, it's the opposite of this guy over that guy. Don't you get 4/3 in that situation for your 0? The instructions say for each real 0, so we don't care about these two. They are not real zeros. They are imaginary zeros. Tell whether it touches or crosses. So how about 0? 0 does what? Touch or cross? 0 crosses. Let's do this. Let's just put a crosses and a touches column. Let's do crosses, touches. Instead of listing that word crosses and touches over and over and over again, 0 does what? Crosses. Put them on this side. Don't care about Mr. Imaginaries, right? That's not part of the deal. Negative 5. Does he cross or does he touch? Even multiplicity will touch. Done with him. 4/3 crosses. Cool. What is the degree of the polynomial? 1, 5, 6, 7, 8. Correct? You add them all up. 1, 2, 3, 7, 8. However which way you go, there's 4 of them here, plus 1, 2, 3, 4 more of them. That was degree 8. Turning points then, 1 less. Sketch the end behavior. It's even, right? So they got to be going the same way. Check out your leading coefficient. He is positive, so that's going up both ways. Hot dogs, bananas.